Hi, welcome. This is another Convergent Technologies computer video. I've done 3 of these videos so far. This is the 4th. I hope people are not bored with them yet. I'm finding it interesting just because this is a lesser known computer system and it has some unique properties to it. If you watched the first 3 videos, you saw where I started out with an 8186 computer with an MFM drive. I got that working, booted some versions of the operating system. I made myself a monitor adapter. So what happened is some people watched that video. In particular, one viewer, Joe Altmeyer, watched it, and Joe worked for Convergent Technologies back in the 80s and 90s when they were developing these computers and the software for these computers. Joe had a couple of computers sitting at home, and he offered to send them to me. He also had monitors, he had modules. So this has allowed me to build together a much larger Convergent computer. I've got 4 modules stacked together here. I've got a 286, a quick tape, a dual floppy, and a Scuzzy disk. I have an honest-to-God Convergent monitor. So what we're going to do is I'm going to go through all of these modules that Joe sent one by one. We're going to look at them, we're going to tear them down, look at the innards, try to get some of them to work. Some will work, some will not work, such as life with computers that have been sitting around in storage for several decades. Parts go bad, things fail. But I think by the end of the video you'll see I got a good helping of this stuff to work. Convergent video I did was a 186 unit, much like this one. I'm not actually going to fully tear it down just because I've already done a video tearing down a 186. I don't know how much benefit there would be to doing it again because most of it's going to be the same inside. But I will highlight a couple of the differences. First thing, we're missing the cover that goes on the side. Developer hardware sometimes can be a little bit rougher than hardware for businesses and consumers, so not necessarily unusual to have exposed circuit boards cover lost at some point, etc. So that brings us to the other difference is the memory boards in here. In my other 186, the memory board was in a nice plastic cartridge that you can slap in and interlock. These ones are just sitting here kind of plugged in loose. Which makes them a little bit more difficult to line up on the connector because the plastic would kind of guide you in. But these are both appear to be like 256K memory boards. It's interesting that one of them has a bunch of hand-wired stuff here. So maybe this was an earlier revision that had to be changed, something like that. That's not unheard of in the computer industry back then. It was expensive to get boards made, so if you had a board made and later discovered a problem, maybe you'd rework it rather than throwing them away and remanufacturing them. A couple really interesting things I spotted on this board. First of all, there's actually a decoupling capacitor that isn't hooked in on one side, so the manufacturing error. One of the legs is bent over and it didn't get soldered. And, 40 some odd years later, here it is, still not soldered. The other thing I noticed, some of these chips are not in straight, like this one here, it's kind of up at the end. So, whatever machinery they had making these things must have had a few little problems here and there. So maybe that's how this ended up in a developer's hands, is maybe these were rejects and they sent them to developers and the developer threw them in and got himself an extra 256K. The other board, a little bit better manufacturing than the one there. There's no decoupling capacitors that are poking up. All of the chips are in straight, and there's no rewiring stuff on it. So that is the 186. I'm not going to plug these back in because it's really hard to get them lined up straight, and I'd rather take my time doing that. So a 186 is great, but what's even better is a 286. So this is a 286 unit. You can see externally it's the same form factor, the same connection stuff here on the side, same power plug on the back. Compartment opens up here on the side. You've got your memory cartridges for your memory expansions, your I/O, just same thing as the other one. We have a model number. Yeah, so it doesn't, it didn't come with a model number, serial number on it, other than this handwritten stuff, which maybe this meant something back then. But anyway, let's take a look at it. So this is what I was talking about with the memory boards. For consumers, they this nice plastic cartridges. This is an XM003 memory board, whereas these are XM001s in there. So these are 1 megabyte, so those are 256K. This memory board says return to Andrew Thurber. Sorry Andrew, I don't think it ever made it back to you. Pop that out. Let's get this 186 out of here. So let's crack this one open. All these Convergent modules, it kind of come apart the same way. Back comes off and you've got a fan assembly. It's got a little header that holds it on out of the way, and then you've got a couple DC to DC converters. The front cover will just rotate on off, and we're into the board. Let's see, I do like to mark these when I take them out. Pull this off here. We've got a guard for the cards. We'll mark this one B. And we'll mark this one A. In some of the modules you will have both converters will be 5 volt. In some of them, one of them will be 12 volt. That's one of the reasons I like to keep them separate. I think they're actually interchangeable because I've mapped the pin out, and one of the pins that goes into this tells it whether to kick out the 5 or the 12 volts. So those are the two DC to DC converters. If you watch my previous video, you'll know that 36 volts comes in on this MDL plug, where it gets down converted into your 5 or 12 or whatever through those. We've got a reset switch here. We've got the I/O board. Let's see what it takes to pull the I/O board. I/O board actually looks a little bit different. It almost might be in 2 boards, so that might be a difference. Oh, this is another memory board. So we've got, yeah, this is very different from the 186. The 186 had a big long I/O board here. The 286 has this little stubby board here, which is just a breakout for the I/O connectors. Go down to the bus, and then it's got a memory card hidden in there. So I bet you that's the same as the memory cards that'll plug in there. This would be a 1 megabyte memory card. Does it say it's an XM003 anywhere? It just calls it a T2 RAM expansion. Let's hold those up. I'll plan on taking pictures of all these at some point. Put them online for people to see them. But let's try to put stuff back together so we don't end up with too much. And let's see if we can put this RAM board. Well, that thing's going to be the devil to get back in. Let's first pull out this next main board so we can get ourselves some room to work. Now we'll put this RAM board back in. Okay, I've got the RAM board back in, and the board I pulled out, this one here, say what it is, GAIO video. So this is a combined video and I/O board, so that the I/O probably breaks out onto this connector through the bus, and it's also got video. Got some kind of Aztec DC converter, 6845. 1, 2, 3, 4, 5, 6. Something's there that could be ROMs. AM9128-10. Here we have an LIA 0502 720143 8833. LIA 0290 720144 8833. The 88 could be a date code. So these LIA, maybe they're, I don't know, some kind of graphics chipset. Who knows? It'd be interesting to look all this stuff up, see what it is. An 8251. Well, that is the I/O and graphics board. Let's put him back where we found him. This one here, what is this? Made in the USA. DMA and interrupt board. So we've got a couple of 8259s, a couple of 8254s, 8259s, 8254s, 8237. So you've got your DMAs, your timers, that sort of thing on this board here. I'll bet the next one is going to be, oh yeah, big heat sink. That's probably the CPU. Just something on this CPU board. At Convergent Technologies, made in the USA. Oh, they're T2 8 megahertz CPU. So CPU is probably under there. Got a couple ROMs. Down here, an 8451. I don't know what that is. Interesting. We've got some socketed chips there. That is our 286 CPU board. So one interesting thing to note, I don't think any of this is probably interchangeable with the 186. It's the same form factor, but you can see the boards, if you watch my 186 video, are quite a bit different. So the I/O board was different, the memory board was different, and the graphics board were different. So they sort of kept the form factor, but they certainly refactored what chips go into what boards. Now the DC converters, I've already went over them in a previous video, but it is a good idea to look at all of the capacitors because I do have one board in my tape drive, which we'll get to later, that actually had a blown capacitor on it. Electrolytics do get old with time, so this was a... Next up, we have an HSD 140. The HSD 140 is a Scuzzy disk expansion. So let's tear this apart. And we find the hard drive is missing. But the reason it's missing is because I'm the one who took it out. So inside of this goes this ginormous Micropolis hard drive. This is a 140 megabyte hard drive. This is what big drives looked like back in the 80s. It's a Scuzzy 1 drive. It's got the 50 pin connector on the back. I want to tighten those back up. Good old Micropolis. So I can tell the story of what's going on here while I'm doing this. The reason this drive is not in there is because the drive as received was not good, and I had to take it out and work on it. So Joe, when he shipped me the computers, he thought the drives were shot in all of them beyond repair. I did pull them out. I did verify that the drives didn't work, but then I got some advice online on the Vintage Computer Forum on how to fix the drives. The first thing I had done was a controller swap. So what I did is I bought a good drive from eBay, and I took the controller off of the eBay drive, put it on the drive that came in the HSD 140. That did not help. But what did work was doing some work on the head assembly. So if you look inside the Micropolis drive, around the front of it here, this head assembly is right here in the front of this thing. I've already turned, this isn't the one that goes with this drive, this is out of a different drive. But this head assembly, it's a voice coil head, not a stepper, moves back and forth like that. But what there's a couple rubber bumpers. There's these two screws, they adjust a stop here. These two screws adjust a stop there that stops the travel of the heads. And they put a little rubber bumper inside of there. And this comes back and it hits the bumper. But what will happen is that as these things get older, those bumpers deteriorate and they become sticky. And what will happen is your head will get stuck in that all the way in position, and the voice coil will not have the necessary torque to break the head loose. The drive will just sit there and do nothing. So the drive out of this HSX 140, all I had to do after following the advice online was open it up, give it a little nudge, and then boom, it took off over here and started seeking, and we managed to image that drive, which I then took that image and burned it back to the eBay drive that I bought. The eBay drive being supposedly tested, verified, and working. And then you see there's a couple slots in here. Can you see the two slots? I'm going to pull just one of these DC converters out of the way. The drive just kind of sits in there loose on those two slots. I like that. See, it's just kind of loose in there. I find that extraordinary, because I would think that those screws would just simply loosen up like immediately. I'm actually going to tighten them, but as I found them, they were just like completely, let's see, can I get my big screwdriver in? Completely loose, and you could just pull the drive right out. That was weird. On top of that, if memory serves, goes this metal bracket right here. Well, here, let's first I'm going to connect some cables. I guess I could have, before we go too much further, let me at least give you a look down here at the electronics. I already put the hard drive back in, but this one, unlike most of the Convergent gear, it doesn't have a separate controller board sitting alongside. The electronics, the Scuzzy controller, is all down here on this sort of motherboard type board underneath. So you can actually see a bunch of little chips. If I was to pull the drive out, you'd see some bigger controller chips and stuff down there under the drive. So that's kind of a departure from how they did stuff with the other ones, where you'd have a separate board and it'd yank out. Not sure. I think I like the other design better because it seems more serviceable. So an interesting thing to note here is there's a little 7-segment display down there at the bottom, which will show our Scuzzy ID. There's no jumpers or anything to set the Scuzzy ID. It must automatically figure it out based on how many modules you've attached to the side and their order. There are DC converters plugged in. Looking over the capacitors. Well, that's interesting. What's that? One of these is definitely newer or different than the other. And like, see, you've got these blue capacitors here. Whereas here you've got kind of these older ceramics. There's a kind of fancier capacitor. So whether these are two different revisions or, oh, and the transformer orientation is different from one to the other. I don't know why they're different, but we will make sure get them put back in the same order we took them out. Urgh. We are going to have to zoom out. Here I have a monitor. If you've watched my 3 other videos, I had to rig up my own solution because I couldn't find a convergent monitor. I had to rig up my own breakout board. Where is it? This gizmo here I designed, I think I went through this in the previous video, to break out the keyboard and video signals and do some inverting and add a speaker and all that. Because the way this architecture works is there is a DB25 that feeds the monitor. This DB25 has your power for the monitor. Also in here is the keyboard signal, the video signal, all kinds of, the speaker signal is in there, and all of that guts is built into the monitor. So if you want to be able to use your keyboard has to plug in through there. Let's take a look at this monitor. It was really nice getting the real monitor, so I don't have to rig up my own solution. And again, this is a good time to say thank you again to Joe for sending me all this stuff. Monitor comes open like that. I have had this recently powered up, so I'm not really going to touch anything in here because I do not want to get shocked. But this would probably look, to people familiar with a CRT monitor, this probably look like a typical CRT monitor. Tilt it so you can get a look in there. Yeah, you've got your usual flyback transformer, your big tube. Where things differ from usual is these connectors coming in here. Which one of these is the DB25 coming in and the other is the keyboard coming out. So I would have really expected there to be like a logic breakout board for that keyboard, you know, and the speaker and all that stuff. But it's actually all integrated into a single board that is also the board for the monitor. There's even a little speaker down in there. Monitors are not really my thing, so I'm not gonna take a bunch of time to look inside this thing. Just suffice it to say, this is typical CRT monitor plus that keyboard breakout stuff and a speaker driver. There will also be a switching power supply that could be this board over here, or it could be built into the main board. A switching power supply that takes the 30 some odd volts that come in over the DB25 and down converts them to 5 volts for running keyboard. Let's put this back together. I believe this is the 14-inch monitor. There's a couple different monitors you might encounter. There's the 14, there's the 12, there's also a color monitor. This one here is monochrome. There may be a VGA monitor. Let's prepare to get this thing powered up. So I am told by Joe that this was his earlier development computer, was this 286 CPU together with that storage module. He must have had a floppy module too, because there's no removables in this. Joe did send me a floppy, a dual floppy unit. Let's not worry about that now. Well, we've got rid of some of the annoying glare on the monitor. I'll focus that in, but let's turn it on and see if it boots. Do that. Turn on the main power. Everything is snugged back down. So spinning up. I'm going to try to focus that for you once it comes up. Okay, so it is booting. I hope that text is going to be readable. So this is was a 2.3, I think, so standard software 12.0. It's trying to do some auto run stuff. So this is the XBus service, the Quick Tape service. We don't have the Quick Tape hooked up. PC server. There was a PC emulator, so that might be that. I don't know. Some network stuff. Joe did also send me an Ethernet module we'll look at in a moment. Mail server, so there was mail capability in this. Modem server. I guess you could hook a modem in and it would have a modem service come up. Seems to be taking a little while here. Loud clunky drive. Got a little bit of a subsystem error. Maybe that was on that modem server or something. And then there's no clock in these, I don't think so. Friday, March 20, 1998, 2 o'clock p.m. Go. There we go. Volume status. D0. D0 is our Scuzzy disk. Look, we've got all this stuff. All kinds of stuff. So this is Joe's developer machine. It, is his hard drive image running on it. This is whatever he had running on here when he stopped using this particular machine. There are everything on here from various source code to his emails to his developer documentation, all kinds of interesting stuff. Now obviously I can't put this up on the web, but I might talk with Joe and maybe with some others about whether there are portions of the artifacts on here that could be contributed to the public domain. Do we have anything that would tell us how old some of this stuff is? Let's see. Well, let's look in S3.0.4 files. Oh gosh, I forgot what it was called, so we'll just use the wildcard. Details, yes. So there's some stuff from 1991 on here. So clearly some of this was still in use. This machine was still in use in 91. So anyway, that is Joe's 286 computer with its hard drive, now running an eBay sourced hard drive, but his original image. Presumably, if we wanted to, we could keep developing on this machine right now, just like it was used back then. Okay, next up is the Quick Tape Drive. It's got a little door here, opens up and you can put your tapes in there for tape backup. I always thought of quick cartridges as fairly small cartridges. In my PC days, I would have like a 40 megabyte quick drive. It took little cartridges about the size of a cassette tape, and I would back up my Windows and DOS stuff. It's a different thing. It turns out those were mini quick. What we have here is the real deal. These are full-size quick cartridges. Look at how big that is. Joe actually sent along this cartridge along with his drive, and this cartridge simply says volume backup. Okay, so let's take apart the tape module. I've already pulled the 2 screws out of the back. Cover off. And then typical of Convergent stuff, we've got controller board on the side, the drive's in the middle, there's a couple DC converters back here. The usual cooling fan with some kind of a controller or something there. And now you can really see the 2 DC converter boards in the back. See in there well to see the back of the tape drives. We've got a big connector goes down to the motherboard from that card edge, and there's a couple 4-pin Molexes for power. Out comes the drive assembly. So you can see inside of here. The motherboard is really pretty sparse. Not a whole lot going on there. Just a connector that comes off and goes. Drives. We have a controller board that plugs in over here. Typical Convergent controller board. Does have some kind of an EEPROM or something there. Have some firmware in it. It's interesting looking at this DC converter. We have a swollen capacitor right there. That electrolytic has seen better days. So unfortunately what I found in the tape drive is not good. There's a roller here that engages the tape. It's used to spin the tape. It's right in there, and it's actually, I don't know if you can see real well, but it's completely flattened off on one side. It's actually, this roller's kind of turned into black goo. I touched this one side of it and it crunched in, and I left a fingerprint in it. So you know what happened. As soon as I put in the tape and I engaged the drive mechanism and it moved that roller up, it just completely flattened the side. I'm guessing over the last 40 years, whatever rubber they used in that just deteriorated. Okay, here is the roller. I think you can kind of see how it just turned into a black goo. That's it's actually soft to the touch. I did measure it as best I could, and it looks to be about a 1/2 inch outer diameter, about a 1/4 inch tall. We'll get it off of there. We could measure the inner diameter. We could try to 3D print one. I don't know if that'll work or not. We'll have to see. Okay, so I did go ahead and print a roller out of TPU on the 3D printer. The problem is I just don't think it's all that round. It just feels kind of lumpy, and I'm not sure it's going to work that well. So I might try reprinting it, or I might try using this one just to see what happens. But we'll see. So you're looking at it after I already tried to fix the roller. That's why you see a green, I don't know how well you can see it, but there's actually a green 3D printed roller in there. There's actually a second board, so this is an archive tape drive unit here. Its part number is underneath there. We'll pull this bracket off and we should be able to see what's going on in there. So there we go. It is an archive. Let's flip it around. And archive 5945L-3. See that well enough? And then there's this second board. It's some kind of controller mounted onto the bottom of it. That's kind of annoying because it won't come off due to this front panel. And now we've got this controller loose. I don't know exactly who makes this thing. I was a little bit surprised it had this separate board in there. Archive Corporation, so it is Archive. It's got a bunch of status LEDs buried inside of it. So it's some kind of controller that goes with the tape drive. And then we've got the tape drive unit itself. So you can see the bad capacitor here. It's actually leaked some crud out of it, and there's some crud on the bottom of it there. We're going to replace that. That is a 220 microfarad 50 volt capacitor. I'm going to put it on the tester and see what the tester has to say about it. It says it is a 45 microfarad. So yeah, it's certainly lost some of its capacitance. I would be surprised if there wasn't more wrong with it than that. Okay, I went ahead and I replaced all of the capacitors on the board. And see, there's 1, 2, 3, 4, 5 of them. Because even though this was the only one that was bad, it's not unlikely that they all could go. This here is a broken quick tape cartridge. It's actually a brand new cartridge. It was new old stock, but even new cartridges are really old, been sitting on the shelf a long time, and it came with a broken drive belt. So this belt, it runs, you can kind of see it here, it runs from here, it runs around the back, goes around this roller, it goes around this wheel, it's down here, goes around this black drive roller, goes up, passes this wheel, comes around here, and it's broken right back there, and you can kind of see there's a bunch of slack in it. It's broken right there. It's probably extremely brittle. So what we're going to try to do is to take it apart and replace it with something called a Plastaband. These Plastabands are substitutes for rubber bands. They're made out of kind of plasticky material. I've been told this will work. It seems to me like this is going to be extremely tight, but maybe you can stretch it out and make it work. We will find out. Okay, here it is, my first repaired tape. You can see the green band here is the Plastaband. Wrapped around this roller, up around there, and around there. And when you run the drive, everything in there turns. You've got the tape nice and tight. I did get a couple little crinkles in the tape in a few places because when I first took it apart it was all spooled loose on one side, so I may have ended up wrecking the tape, but mechanically it's back to being the way it should. So we've actually got it messed up a little bit. I think the tape is supposed to go inside of this pin and inside of that pin. Just looking at another cartridge, you can see it's clearly going inside of that and inside of that. Now this is a non-magnetic, this stainless steel tweezer. Plastic tool of some sort would probably be even better. Yeah, I can see some crinkles and some mess and stuff on the big spool that makes me a little bit concerned for what kind of shape the big spool is in. Okay, here we have the dual floppy unit. It actually only has one floppy drive installed, this one here on the left. The one on the right is missing. I asked Joe about this. He says it probably got scavenged for something. Now the dual floppy, sometimes you would use those with like the 186 computer from what I've read, and it would just be a floppy based computer. You'd have no hard drive in the PC, but maybe you would have a network connection to a server and get your hard drive storage there, and the floppies would be just for your removables. Or maybe you would use this with something like the Scuzzy Disk Expansion. And I haven't asked Joe, but maybe that's what he did use it with, because his Scuzzy unit does not have a floppy with it, so I would think his 286 computer, maybe it had the 286 main unit, floppy, then the Scuzzy, maybe the tape thrown in there. But anyway, this is the dual floppy unit. As usual, the form factor is exactly like all of the other Convergent stuff. Let's crack it open and take a closer look. And we've got our two DC-DC converters. Now one of these will be a 5. History is my guide. It'll probably be the one on the right. And then one will be a 12. So you can see down here, all the electronics are on the bottom on this floppy unit. We do have a controller chip. It's a Western Digital 2797. Each floppy's got its own cable. The other cable goes here. It's missing, as is its Molex power cable. Let's look at the drive itself. Here is the drive. Is there a label on it someplace? Maybe the label underneath. Mini flexible disc. It is a model M4853. This is serial number 67201 by the Mitsubishi Electric Corporation. So anticipating that one of the drives was missing, I did go ahead and I bought myself a second one. Be identical to the first. So even though I attempted to buy the very same drive on eBay, it's a little bit different. So here's the eBay drive, I've labeled it. Here's the Convergent drive. The Convergent drive had an additional jumper down here marked HC. This one doesn't have that jumper. The Convergent drive also has this jumper here, which I think is marked MM. This one doesn't have that one. And then the Convergent drive has also got a bank of jumpers over here, which we don't have. So I'm not sure that this eBay drive is going to work or not, because I don't know if those jumper settings, maybe they're just the defaults on this one. I'm going to have to look up the revision differences between these two. Okay, let's take and put it back together. We're going to keep the original drive in the same spot that it came out of in here. Now I do also happen to have a second floppy unit. This one didn't come from Joe. This one I bought on eBay. It's also a dual floppy. Seems much the same as the other one. Okay, so let's try adding a floppy unit to our stack. So we've got the 286. We'll plug that floppy unit in first. And we've got our HSD 140 hard drive. Power on. Boot up. Volume not mounted. Maybe if we initialize it. High volume. F0. Call it the floppy. Okay. Just going to try to format it. Device not ready, so that drive not working particularly well. Boy, that's just weird. It does not like to eject floppies. Yow. My disk is stuck in there. I'd like to have to pull out a disk like that. Well, that's just weird. Okay, the floppy unit's going to need a little bit of work. I do have a second floppy unit. This one came off of eBay. So let's try stacking him in here. I've actually had this one here sitting on eBay since I got my first Convergent computer and did my first video, and it's just kind of been sitting around for, I didn't want to latch. Always got to check these latching mechanisms. Make sure they slide smoothly. It does. Pins look good. There, I think we're latched up. So I've had this floppy unit again. High volume. F0. Call it the floppy. That one sure doesn't sound as awful as the other floppy did. Disk is now being initialized, so we're formatting floppy disk. Okay, it completed formatting. That took a really long time because it did, what, 8 passes of surface test. That seems to be the default. Volume status, F0. And we should have a newly initialized volume. It has a sys directory, and the sys directory has a few files in it. 0 sys star. Let's do details. And so it's got the usual. It's bad block, a place to hold the crash dump, a file headers holds the headers for the files, there's a place for the system log, the master file directories, the mastery list of directories. Sysimage is where you'd put a bootable OS, but it has no sectors allocated to it. Basic file. Okay, let's try adding the tape unit and see what happens. Put it in the first slot, I think. Okay, so let's insert a tape. Latch it. Does that seeky thing again. And then we're going to do a quick retention. So I saw a blink and then the seeking, but I don't think it's actually running. I think we've got problems with the quick tape unit, that it does not engage the motor. So it processed like a start unit or something, but yeah, it just didn't do anything. So that's where I'm at with the tape drive. I don't know what the problem is with the tape drive. Okay, so here we have a pair of thin modules. They should pop apart. Start with this one here. This is a Scuzzy Expansion. So we actually have a different DC to DC converter design. So the other ones would have a pair, one on each side. This appears to be an integrated module. It probably puts out both the 5 and the 12. Not a whole lot to the Scuzzy Expansion, because what it really is just a breakout for another Scuzzy connector. So you can see this over here and corresponding one on the other side. When you add the main Scuzzy, the HSD 140, it adds this extra connector out here. And I think this is your breakout for additional Scuzzy modules like this one. And you just keep stacking these on the end, and they hook up to that Scuzzy breakout and give you additional Scuzzy drives. But this one here is the really interesting one, because this is an XE001 evaluation unit Ethernet. So these Convergence computers, generally they use their own networking standard. They had these like DB15 connectors that would network. So I think Ethernet is fairly new and fairly rare to their product line. For those of you looking for an RJ45, you have to go back a little bit further in time. This is a coax for the 10 base 2, I think, connector. And you've got this AUI connector, which you could plug an external adapter in to go to either thick Ethernet, or you could go with the external adapter to the little thin Ethernet too. I actually had one of these floating around from another piece of vintage equipment, and what you could do is you could take this, plug it into there, and then you'd have your RJ45. What do we have here? I would say, based on the big transformers, the big caps, and the fuse, this is some kind of a power board. Nothing really says in here what this is. The board down on the bottom is called a multi-use motherboard. This board here would be our Ethernet board, 3Com. So they outsourced this to 3Com to make it. I don't know, maybe neon light bulbs were just the thing back in the day in old 10 base 2 Ethernet adapters. I don't know. This guy ready to come out yet? Convergent really like these little snap rivet things. I think that's probably what's holding that converter in. Whoops. So there we go. Looks just like all of the other DC converters, so I think this is probably a standard one. 1, 2, 3, 4, 5 capacitors. Some of them are a little bit different here and there, but they're probably just different revisions of it. Here's a view of the multi-purpose here's a view of the multi-use motherboard. I wish I knew more about this gigantic connector here and this associated really big DC converter that went with it. I don't know what that's for. Did this module need a different voltage than all the other ones? Maybe this is actually a step up. Maybe it needed like 48 volts or something. I don't know. I'd have to learn more about Ethernet back in the day. Anyway, let's put this thing back together again. Okay, we are up to the last module, and perhaps the most interesting one. This sort of 4 wide is the 386 module. Looking at the back, it doesn't have the cable entry on the side, it's actually got cable entry on the back. It's quite a bit different. A bunch of connectors down here across the bottom. You've got an integrated power supply, video connectors over here. There's actually expansion slots in it, getting kind of PC-like there. Take a look. Let's pull some of the screw tabs were broken, but some of them here are still in. So let's pull the lid off. And what's interesting most about this one is that it is a very different design internally than the other ones. You know, if we look at the side, we will see that it does still have the same good old X bus as all of the other Convergent modules, so you can still plug your tape or your dual floppy or your Scuzzy Expansion or whatever into the side of this. So they've kind of kept the external form factor, but we'll see they've changed up the insides quite a bit. We have the memory expansion board, a bit dusty, and it uses SIMs. Look at that, you could put a lot of memory in those. I think these are either 1 or 2 megabytes. These might be 2 megabytes each, because I think this is 8 megabyte computer when I booted it up. So that's interesting. Certainly room to expand. Over here, this pops open. We've got our card cage there with a video board in it. Video board is the GC104 VGA graphics. So this is VGA capable. But even though it says VGA, it's still that same weird 25-pin Convergent connector. Your hard drive would go here. What's in here is not a hard drive. This is, inside of a 3D printed case, is a Scuzzy to SD adapter that I've put in there. So let's pop it out of the way, tilt the computer, and you can see your motherboard is way down there at the bottom under all of this metal and drives and stuff. So I'm not going to take the time to tear all this out so we can go look in there. It is not what you would think is conventional PC motherboard. It is, of course, it's got the X bus and it's got this slots over here. It's very different than what you might find in a PC motherboard. Scuzzy drive would go here, your floppy's there. This here is some kind of a power supply. It's AC to DC power supply, no more of that DC converter and external power brick stuff. Let's put that back on. So what did it come with for a hard drive? Well, it came with, another one of these gigantic Micropolis drives. just like the one in the HSD 140. It is a 146 megabyte Micropolis, gigantic heavy drive. So there's really a sad story behind this drive. When I got these computers, we thought the drives were shot. We did not expect them to be viable. So I really didn't do much with them. Then one night, in the middle of the night, I decided, hey, I'll power this thing on and take a look at it. Not expecting it to boot, but it did boot. Booted up this drive right here. I was logged in. I'm like, oh wow, it's actually working. That was great. So I took and I got out my my MFM expansion unit, rebooted or powered down, attached that to the side, booted up. So I had about 40 megabytes of free space, and I started copying files off this drive onto that MFM expansion. Filled up all of the free space I had there. I went to power it down, clear the space on the MFM expansion, power it back up. It took me about a minute maybe to do that reboot, and this drive wouldn't reboot. The drive came up unready, the computer wouldn't boot. I'm like, uh-oh. I repowered it a couple more times, it still wouldn't come back up. I took the drive out, I put it in my Linux PC. That's what I should have done in the first place. If I'd have done that in the first place, we'd have been able to image this. But I put this in my Linux PC, drive comes up unready. At that point I got on the Vintage Computer Forum and I asked the guys there, you know, what do I do about this? And there was someone, a user DJG, actually told me how to go about fixing these drives. And I followed his process on the HSD 140 drive. First, freed up the stuck head, imaged that drive just fine. I had great confidence that I'd be able to do the same with this drive. But this drive did not work. You know, I cracked it open, nudged the head, it wouldn't do anything, it wouldn't seek. Just sits there and spins and goes in not ready state. After that, I think I found the signals on the controller for the servo track and attached my oscilloscope. And the servo track was not reading at all when I moved the heads back and forth on the disc. It's like it's getting nothing from the head, at least whatever head is trying to get servos from. So I continued to play with it for a while, just could not get anywhere with it. Eventually I found what looked like a little tiny piece of black plastic. Pulled that out, looked at it close up, and realized that is a disc head. And a disc head should not be just loose floating around inside the drive. Obviously something really bad happened. That disc head got detached from assembly. Of course that's shot. So I pulled out the head assembly. I've already showed this off earlier in the video when I was talking about the HSD 140. This is the head assembly out of this drive. You can see on each one of these here is a disc head. The lowermost one, no head. That's where it came from. So my suspicion on this, there's a couple explanations for what could have happened. We know it did run for like a couple hours when I copied that initial 40 megabytes off, then I rebooted, it didn't come up. I would assume that was the same problem as the others, where the deteriorating rubber bumpers allowed it to get out of alignment and it couldn't find its servo. Then after that, you know, after I fooled with it a bit that night, I did let it sit till morning, I powered it up. What could have happened is traditional stiction. And stiction, when that happens, is a drive that's old. You run it for a couple hours, warms up, then you let it sit overnight, it cools down, and the heads will get stuck to the platters. That could be what happened here. It could be this bottommost head got itself stuck to the platter. You turn the machine on, and then if the motor's strong enough, it rips the head off of the assembly. It's one option. What could have happened? The other thing that could have happened is these bumpers on this assembly had completely liquefied. They were just black goo, you know, and that will allow this to move a little bit further inward than its set point. So what could have happened, this could have moved far enough inward that it actually contacted the spindle in the middle of the disc. The spindle's probably bigger down there on the bottom where it goes through the bearing and, you know, goes into the case. It's possible that that head came up, it hit the spindle, and just, you know, at 3600 RPM would have just whacked the thing right off of there. Or it's possible that while I was trying to repair this disc, you know, I somehow screwed something up. I don't remember any adverse sounds, no grinding, smacking, nothing that would have indicated that a head had been catastrophically destroyed like this. But obviously it did happen at some point. And as soon as you find that head in there, you're pretty much guaranteed it's not going to work because it needed that head down there. So I did transplant the head assembly out of the HSD 140's drive. I put it in here. I actually built myself a jig so that I could do fine adjustments on the stops on these heads, get it in exactly the right spot. For the servo track, managed to pick up a good servo track with my oscilloscope. And just like the HSD 140 when I fixed it, the head shot out there to track 0, just like we want. Thought, okay, I'm in business. But then it's sitting there at track 0, and every 10 seconds it bounces back in and seeks back out. And it never goes into ready state. It just does that every 10 seconds, goes from track 0 to somewhere in the middle, then back out to track 0. So something with this drive is still not right. It's beyond my ability to do anything at all with it. Almost assuredly at this point I'm making things worse rather than better. And I'm just fighting a losing battle where I don't have the tools or the expertise to further work on it. To send this off to a commercial drive repair place, if they could even fix it at this point, which we don't even know if they could, the bottom platter where this head went to hell could be all scratched up. Even if they could fix it, we're probably talking thousands of dollars had I not messed with it. Given that I've messed with it, it's, you know, probably even more thousands of dollars or even tens of thousands of dollars. Who knows? It may cost a lot to try to get the data off this disk. I suppose if you do work for a commercial storage recovery place, or you know someone who does, and they want to do a pro bono job and get themselves featured on a YouTube spot, put me in touch, and I could send you this disc and you can try to do something with it. We do think this disc has Joe's development environment as of when he stopped working. You know, it would have the latest source code, the latest tools. I did copy, like I said, about 30-40 megabytes of source code off of it, but I don't even know what the rest of what was on there, because I was really thinking I was just going to copy 30, then copy the next 30 to 40 and just keep doing that all night. But after that first copy off, we just didn't get the rest. So we didn't get the tool set, and we didn't get the any more files. So like I say, we got some of it. Kind of a mixed result. We had some good luck. We managed to save the drive in the HSD 140. We managed to save a third of what was on this drive, but we managed to lose 2/3 of this one. So a little bit of a bittersweet victory. So back to the 386 computer. I don't think I'm going to tear into this thing that much further. Like I say, you've got to really pull all this metal, even the power supply, to get down there and get a look at the main board. This is just another one of your standard floppy drives. So I did with my Scuzzy to SD adapter here, I did take the image off of the HSD 140, the one that we saw booting on the 286 earlier. I put it on this, and we can boot this 386 now. So it does boot with that older image just fine. Convergent seems to be pretty good about newer computers booting with older images, so that's not surprising. So this unit does function. I'm not going to power it up because it's same image. It's going to look exactly the same from a boot up standpoint. But this is really cool, this 386 computer. It would be fun to fully deck it out with memory and put, I don't know, 32, 64 megabytes, whatever you could put on this thing. It'd be interesting to see what it does. This would have been probably state-of-the-art back then. So that's it. I hope you've enjoyed these videos on these Convergent computers. I've enjoyed tearing them down, and I've enjoyed trying to get them working. We have a couple things left to try to fix. I would really like to get that tape unit working. I did actually find the manual for the archive tape drive, so I could try to do some diagnostics on it, just because old tape drives are kind of fun to play with. The other thing I'd like to do is I'd like to get that Ethernet module working, because let's face it, Ethernet is really handy to have for getting files on and off of these computers. It would be really nice to just FTP them, or to perform operations. It'd be nice to telnet. So even, you know, the earliest rudimentary Ethernet type IP, TCP software that you had back then would have been really, really handy to have compared to trying to do it over, I don't know, a modem connection or something. So anyway, that's it. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.